Okay, so we're going to start with problem number 7, where we have a proton with an electron floating around it, and the distance between them is 53 picometers. So the first question is, what is the force on the electron from the proton? And we're just going to do the formula of Fe. It's equal to Q1 Q2 times K over R squared, which is equal to K, which is equal to 10 to the 9th, times the charge of an electron and a proton, which happens to be just the same except positive and negative, but when you multiply them together and take the absolute value, it won't make a difference. So we're just going to say 1.6 times 10 to the negative 19 coulombs squared over 53 picometers, which is 10 to the negative 12 meters. So 53 times 10 to the negative 12 squared to get 8.202 times 10 to the, I believe that is negative 8 newtons. Cool. And then for the second problem, we're asked to find the acceleration of the electron. For this, we're going to need its mass, which is mass of electron is equal to 9.11 times 10 to the negative 31 kilograms. As we know, force is equal to mass times acceleration. So the acceleration is equal to the Fe that we just got, divided by the mass of the electron. So that 8.202 times 10 to the negative 8 newtons divided by 9.11 times 10 to the negative 31 kilograms to get the centripetal acceleration of 9.0035 times 10 to the 22 meters per second squared. And then for C, we are asked to find its linear momentum. As we know, linear momentum is equal to I omega. And I'm going to erase the board before I do this. So we're going to start here. As we know, C is equal to, for question number C, linear momentum is equal to I omega. And then from the previous question, we got the acceleration of the electron is equal to 9.0035 times 10 to the 22 meters per second. And then we're going to find its I omega, and by finding omega, we know that omega is equal to V over R. But we also know that centripetal acceleration is equal to V squared over R. So V is equal to the square root of AC times R. So we're going to plug this in, this number, and multiply it by the 53 picometers. So 53 times 10 to the negative 12 meters. And we get that that is equal to 2184459.13 meters per second. And then we know omega is equal to V over R. So we're going to divide that number by the 53 picometers to get 4.121621 times 10 to the 16th radians per second. And I'm just going to erase this part to make room so we can find the moment of inertia. So then we know that inertia, since this is a point particle, it doesn't really have a shape, is equal to mr squared. And we know the mass of the electron, which we stated earlier, is equal to 9.11 times 10 to the negative 31 kilograms. So I is equal to 9.11 times 10 to the negative 31 kilograms times the radius squared, which is the 53 picometers, or 53 times 10 to the negative 12 meters squared, to get 2. That's a 5. 559 times 10 to the negative 51 kilograms per meter squared, and L is equal to I omega, so we just multiply these two numbers together to get 1.0547. That's really messy. I'm going to rewrite that. So I wrote my word, 1.0547 times 10 to the negative 34 kilograms times meters per meter squared per second. Yeah, and that's the linear momentum.